The Caste System, C-A-S-T, an acronym standing for cos, all, sine, and tan, and this is using a Cartesian plane, just an XY axis. You remember the angle starts here. Caste starts in the fourth quadrant and then works around counterclockwise. So these letters stand for cos, all, sine, and tan. All meaning
all of the ratios?
Yeah, sine, tan, and cos. And this is where the ratios are positive. So here all of them are positive. Here just sine is positive. Here only tan is positive, and here only our cos is positive. Given the tan of some angle theta is negative 1 over 1, we can see that this would exist in quadrant 4 and quadrant 2, not in these quadrants. Okay, so let's draw some terminal arm to start. We don't know the reflex angle, but we can figure that out with the given ratio. For tan, what does this ratio mean for the numerator and the denominator? Well, you might remember SOHCAHTOA, where tan stands for the opposite side length over the adjacent side length. So we're going to write our angle theta. Where do we put our angle theta relative to our terminal arm?
Between the angle and the x-axis.
We always put our angle theta as the reflex angle between the terminal arm and the x-axis. So that allows us to set up our triangle, which would have a right angle with the x-axis. Okay, now all we have to do is say that the opposite and adjacent is equal to 1, and because we're on a Cartesian plane, we have to follow the positive and negative coordinates. Positive 1 for x and negative 1 for y.
Would this one be a special one because that's the measure one?
We can recognize we have a special triangle. The lengths are 1, 1, and root 2 with 45 degrees and a 90. Therefore, the reflex angle is equal to 45 degrees, both here and here. This is our reflex angle. The question says we have to provide angles between 0 and 360, or 2 pi. So what that means is we need to give the angle as an absolute angle. Absolute angles originate from 0. So here's the first, and here's the second angle. So our first angle, theta 1, will be the first 90 degrees plus another 45 in here. We know this has to be 45, and we know this is 90, and that's 135 degrees. The second angle, big circle here, call it theta 2, is equal to 315. And we could get that a number of ways. We could add 90 and 90 and 90 and 45, or we could realize that this is equivalent to 360 degrees, and we could subtract 45 from 360. Most people do it that way. And so that is 315 degrees. So we've provided our angles between 0 and 2 pi. Now we could do this in radians. Actually, we should do this in radians. Because the interval is given in radians, we should convert from degrees to radians now. The way to convert from degrees to radians is to multiply by pi over 180 degrees, and then reduce the fraction. Most people should know how to do that. I'll show it in another video if people don't. We would get 3 pi over 4 radians and 7 pi over 4 radians. It's not necessary to state our first angles in degrees. we could just go straight to radians. So if you like, we could do everything in radians, and I think we should actually. So this part of the video will show how to go straight to radians. So let's get rid of these degrees. We know 45 degrees is pi over 4. And we know 360 is 2 pi. 90 degrees is pi over 2. 180 degrees is pi. 270 degrees is 3 pi over 2. Remember, pi is 180 degrees, so 3 times 180 divided by 2 is 270. Okay, so let's get our principal angles, theta 1, theta 2, directly in terms of radians. So theta 1 is, well, we could do a number of things. We could do pi over 2 plus pi over 4, or we could do pi minus pi over 4. So theta 1 would be pi minus pi over 4. So we're doing the 180 and subtracting the reflex angle of pi over 4. And to do this, remember, we need to have a common denominator to show our work. Most people could do this in their heads, but I'll show the work. So we would have 4 pi minus pi, which is 3 pi over 4 for theta 1. Theta 2 would be the full 360 degrees, or 2 pi minus the reflex angle pi over 4. Showing the work, we have a common denominator. 2 pi turns into 8 pi over 4. And when we subtract these, we could see the 8 pi minus pi would give us 7 pi over 4 radians. The preferred way to do this would be to go straight to radians, because the question states the units in radians to begin with.
Yeah.